Mr. Paul Guillaumot. So Mr. Paul is the founder and the direct CEO of Spare Part 3D, and it is based out of France, and it is on-demand production. And he is been at the forefront of adoption of additive manufacturing. So his insights are more than welcome. Mr. Paul, can you hear me?
Yes. Hello, Ankit. Do you
Yes.
hear me well?
How are you? Yes, yes.
Good. Thanks a lot for introducing, and thank you for giving me the time to present a little bit our insights on the topic. So maybe just I present myself quite fast and dig into what we know, and I'll focus on how to be informed AM better, but mostly for the spare part topic, which is our really expertise.
Sure.
So myself, I'm French. I'm based in France. Have been in the AM field for 5 years now. I've got a background of mechanical industrial engineering, and I've been strategic consultant my beginning of career with Oliver Wyman, and a spin-off of McKinsey and Oliver Wyman. So I've worked my entire career only in the industry, and I was willing to come back to AM back in 2015, knowing that the technologies were booming, and the technology development were booming, but at the same time, the application within the industry were very more scarce, and it was difficult to find exactly how to leverage AM for different application, and especially with regard to the capabilities to distribute production. So we decided to work on producing spare parts for various industries, and maybe what I would like to introduce is a little bit the spare part problem, because you've presented earlier on some of your cases, and the problem with spare parts is when you're a spare part manager or resell your spare parts, or in industrial doing maintenance on a system, managing spare parts is usually a nightmare, and it's a cost. And you're always trying to do trade-off in between having availability of parts, which means having a high inventory, or risking to have shortages. So you're trying to do the less worse solution that you can get, and you are limited very often by the fact that your supply chain for spare parts is not specifically done for spare parts. It's done for first-man product, and therefore sometimes and very often inadapted to produce low quantity and demands and deliver it quickly. So you end up having MOQ, minimum order quantities that are high. That's the case especially on plastics. You end up having lead time to delivery that are high when we are talking about on-demand order production, which makes it a complex and a very interesting field for on-demand production with AM. And I would like to address a little bit what the business cases that we see on spare parts. And everyone, or I'll say most of our customers and people working in the AM field see the opportunity of producing parts for AM related to the stock, ability to reduce stock. But if we go a little bit into the details of the business cases, we usually found three big areas of problems. I'd say the first one is related to obsolescence. So obsolescence is whenever you are unable to reproduce a part, because if you're producing plastics, you have lost the mold or broken the mold, or simply because your supplier is no longer existing. That happens very often on industrial equipment systems with assets that have a very, very long duration time. So like in railway, nuclear power plants, energy in general. Then the second business case is shortening lead times. A good example is around metal parts that are coming from casting or forging. These conventional processes are often very long lead time to procure, and the ability to produce parts and not necessarily reproduce. I'm always supportive of design for additive manufacturing when there is a business case to do so. The ability to produce these parts on demand with shorter lead time can have a drastic impact, especially when it comes to shortening the impact on or reducing the impact of the business by shortening the delivery time. And the last one is on the stock. And on the stock, when you think about it, the problem is very often related to MOQs in reorders. So reducing reorder value, reducing the cash going out on the reorder values, and eventually, and we see that in with a lot of industrials, providing the ability to scrap part of the inventory and being able to shift to an on-demand production methods, again, because you can lower your MOQ. Yeah. And the economics can be quite impressive with this. So that's not, also we're talking about scrapping, and that's usually a risk, but that's not a business case to be forgotten. And generally speaking, what we see is that there are quite a lot of difficulties to be able to apply these business cases. And as Yain said just earlier, one of the real problems is to find parts. And finding parts is difficult because it means finding parts from a technical perspective, as well as from an economical one. So finding these parts that will be in these business cases I just mentioned, but at the same time, having the ability to do the process that Ankit, you described at the beginning of your conference, which is from the specification to the solution. How can I address that from a systematic standpoint when I have 100,000 of spare parts, to be able to find the right parts to work on? And usually what we see is that customers and companies, industrial companies that are looking on spare parts, employ 3D printing companies, OEM makers, service bureau that comes in to help provide their expertise on finding spare parts, and that works well. That works very well in finding parts in the order of magnitude of the hundreds, I will say. But that makes that can become a difficulty when it comes to scale. And actually, that's our business. That's what we do at Spare Parts 3D. So we've got solutions called DigiParts that helps to standardize and automate this process from specification to business casing, with everything around costing, identification of the business cases, and then, of course, you end up having business cases or not when you know exactly what's going to be your lead time and what's going to be your production prices. So that's where working close collaboration with Service Bureau for us is essential, and having a consistent sourcing and supply base with AM is a challenge today for a lot of companies, but is an important requirement as well to be able to get the best out of AM. Yeah, that's pretty much all I wanted to introduce. I'm happy to discuss further and answer questions if any.
Can you help us with your unique business idea of just going to specific markets on the spare parts and just working on the development of these spare parts for your end customers, and your involvement with the service bureaus, as you have already mentioned about it, and maintaining that quality standards with your customers itself? So, Mr. Paul?
Yes, thank you, Ankit. I mean, in terms of the spare parts, regarding the objectives and how to, what's leverage that you can use with AM, I've kind of already quite introduced that earlier on. What our point of view is what we are providing is kind of being solution provider to help industrials to scale that to the spare part business, knowing that every time you need to do an analysis, every time you want to do a technology transfer for a given part, it's some work in terms of engineering, in terms of purchasing, and because for spare parts, the value of AM is to do it for high mix, low volumes of parts. you need to systematize this to be able to have a ROI, basically. Else you spend too much engineering compared to the cost savings that you're going to get out of your parts. So that's basically what we are doing. In terms of the production, the sourcing, I cannot agree more than what Mr. Atta and Yang has said. It's just being crystal clear on the requirements and have everything written down in terms of what's your expectations from the technologies that you're going to be using is very important. It's quite difficult today because there is no standard still, or very limited standards on the AM technologies and with the different materials. But it's extremely important to align whether we are, for us, whether it is with the customers or with the suppliers, the contractor, regarding the specifications that we're gonna target to make sure that there is no misalignment. And quite often it means that when we are talking about the spare parts, it means that having laid down clearly what is the specification required for the spare parts in terms of, you mentioned a few examples in terms of corrosion, tensile, tolerancing, and this is a groundwork that is difficult, that is quite easy to be done on new product, that is more difficult on reordering of parts. But that is absolutely essential to make sure that there is no difficulty down the road.
Regarding the part screening and these activities for your end customers, how do you go forward with design for additive manufacturing, or using the same design for your customers and selecting a right material for your customers? Mr. Paul, can you throw some light on that?
Well, it's quite different within plastics and metals, say, because again, on spare parts, most of the time we are talking about small volumes, small quantity, not the GE applications. So for plastics, it's very rare to go for topological optimization. It makes sense from time to time to do a design optimization for design for manufacturing, I'll say, and a little bit of weight reduction. But this is a trade-off in between engineering work, engineering cost, and the cost savings on the production. And which trade-off in plastics is often beneficiary to not doing any redesign on spare parts from our experience. Well, also on metal, it's pretty much the other way around. As long as there is some ability to reduce mass and optimize design the design for manufacturing, the potential savings usually are way above the cost of the engineering time. So that makes sense, and we do it quite often. So for us, it's an economical trade-off to be assessed based on the geometry of the parts.
So can you make us understand about the software for the part screening which you have developed with Spare Part 3D itself? So can you just throw some light on that?
Yeah, well, it's we kind of build a funnel to screen the parts, starting from the most available data in the companies, because that's often one of the difficulties, not to have a full PLM system with all the design, the CADs, and everything perfectly filled in. So what we screen usually first is based on metadata. So the typology of parts. We build up clusters of parts, group of parts from functional perspectives. So it ends up being part types, what we call part types, with similar characteristics, and for which we associate all the functional specifications, going from again, as we mentioned, mechanical, temperature, flame retardancy, biocompatibility, whatever you will have on a specific environment of use, and we select materials based on those specifications. So we have automated selection of the materials and processes based on those selections, and then we narrow down the analysis based on business casing. So again, looking at the potential savings as compared to once we've got a material selection, as compared to conventional, And once we go further down the funnel and we have analyzed this metadata to have a first technical economic assessment, we work on the 2Ds and 3Ds, and so on the 3Ds we go and look for the opportunity. We validate the printability of the different processes. We look for the opportunity for the design for additive manufacturing and potential cost savings through that. So it's kind of different steps process, but that is that you can update, that can the entire analysis can be redone instantly on the soft every time you add a new parameter, every time you add new information.